Assalamu alaikum. This is the third lecture of your subject Traffic Engineering and Road Facilities, and we will continue from where we left off in the previous lecture. We were discussing the vehicular characteristics that affect our traffic system. Then we discussed the static characteristics and the dynamic characteristics. Then we shed some light on the vehicle dimension, that was one of the static characteristics, and we discussed it in some detail. Today we will continue with another one of the static characteristic, that is the weight. Weight is another static vehicular characteristic. As you can see on the screen, it affects the pavement thickness and it affects the gradients. I had told you earlier that weight affects the structural design of the pavement, which means the pavement thickness in effect. More the weight of the vehicle, the pavement thickness needs to be more, and vice versa. Obviously, it also affects the gradients which can be given in the road design. You see, if the weight of the vehicle is more, we cannot provide steep gradients, can we? In fact, the thing is that the limited gradients are governed by both the weight and power of the heavy vehicles. Alright, so what needs to be done is that the weight needs to be standardized so that we can give gradients and the thickness of the pavement can be given in a feasible manner. So what was done, that the maximum permissible gross weights and axle weights have been standardized by the IRC, the Indian Roads Congress, about which I had told you earlier, in the following table or in the following manner, in which you can see that the vehicle type is on the left hand side. The different vehicle types which you had seen in the previous lecture, you have that. If you can open that slide also, if you can see that lecture, the different type of vehicles, the 2S1, 2S2, you can see them, and accordingly you can see the maximum permissible gross weights and axle weights on the right hand side of the table, and which is given in terms of the weight on front axle, the weight on rear axle, and the tandem axle, as you can see on the screen. So this was the weight of the vehicle, one of the static vehicular characteristics. Moving on, now we will discuss one of the dynamic vehicular characteristic which we had enlisted earlier, that is the power of the vehicle. See, more the power of the heaviest vehicle, which heaviest standardized vehicle, steeper is the gradient we can provide, isn't it? And if the power of the heaviest standardized vehicle is less, the gradients we can provide should not be that steep. I hope you're getting me. The power of the heaviest vehicles and their loaded weights govern the permissible and limiting values of gradients on the roads. Isn't it? It's common sense. In this regard, the total resistances to traction, the resistance which is given to the vehicle, to traction, consisting of these points: inertia, rolling resistance, air resistance, and grade resistance are considered. From the total capacity and power required to overcome the total tractive resistance, it is possible to determine the speed and acceleration of the vehicle, which in turn is useful in traffic regulation, as you see on the slide, in planning and in design. So this was about the power of the vehicle, which was one of the dynamic vehicular characteristics. Moving on, now another dynamic characteristic is the speed of the vehicle. What does the speed of the vehicle affect? These are the points which are enlisted on the screen. It affects the side distances. What are the side distances? These might be the stopping side distances, the overtaking side distance. The stopping side distance means the distance required to see an object and perceive an object and act accordingly, in order to sight and react to an object, that is the stopping side distance, or in order to stop a vehicle before an imminent danger. Okay, or it could be the overtaking side distance, this side distance required to overtake a vehicle. The super elevation, the cant or the banking, as you might have read it in that way, the super elevation of the roads. What happens also that the super elevation of the road affects the length of the transition curve and the limiting radius on the horizontal curves also. Hence the speed of the vehicle affects those parameters as well. Now the speed of the vehicle also affects the length of the transition curves. We had read about the transition curves in our previous semester, you must remember it. And the speed of the vehicle also affects the length of the transition. If you remember the length of the transition curve formulas, the L part is everywhere, the length part, and so the speed part is everywhere, so the length of the transition curve is dependent upon the speed. We provide transition curves where? On valley curves and on humps. So the speed of the vehicle affects the length of the transition. The speed of the vehicle also affects the width of the pavement and the shoulders. It affects the design gradient, the capacity of the traffic lane, the design and control measures on intersections. So these are the points which are enumerated in the slide. So what we can conclude is that the speed of the vehicle controls most of the geometric features on these roads. The speed is one of the most important dynamic vehicular characteristic, we can say that. Moving on, the braking characteristics. As you see on the slide, the braking characteristics of the vehicle affect the safety of the vehicle operation, the stopping distance, and the spacing between the vehicles. The deceleration and braking characteristics of vehicles depend on the design and the type of the braking system, whether the braking system is mechanical or fluid or an air brake, and the efficiency of that braking system. The safety of vehicle operation, stopping distance, and spacing between two consecutive vehicles in a traffic stream. If you can imagine a traffic stream, then the vehicle operation, the stopping distance, as I said, and the spacing between two consecutive vehicles in this stream is affected by this braking capacity, isn't it? And thus the highway capacity and the overtaking side distance requirements are also indirectly affected. In this way, the braking characteristics of a vehicle affect the traffic characteristics in general. This braking characteristics was one of the dynamic characteristics we discussed it. Okay, so this was all about the static and the dynamic vehicular characteristics. Thank you for hearing me out, and I hope you are getting something out of these video lectures.